Carolina Clinic is considering investing in new heart monitoring equipment. It has two options. Option A would have an initial lower cost but would require a significant expenditure for rebuilding after 4 years. Option B would require no rebuilding expenditure, but its maintenance cost would be higher. Since the Option B machine is of initial higher quality, it's expected to have a salvage value at the end of its useful life. The following estimates were made of the cash flows, and the company's cost of capital is 11%. Okay, you see the initial cost, the annual cash inflows and outflows, and other items related to the two options on the top part of this slide. Now, here are the requirements. For Part A, we need to compute the net present value, the profitability index, and the internal rate of return for each option. They give us a hint. To solve for internal rate of return, experiment with all alternative discount rates to arrive at a net present value of 0. And Option B says which option should be accepted. Okay, now let's take a look at the solution to this one. And you've seen that I've moved the text of the problem down near the bottom, and I've done that so that when we illustrate, or when I illustrate how I solve this, which I'll do using Excel in a multimedia format, I'll show that up top so that you have the numbers down below that you can see where they're coming from in the video. Also, when the video starts, if you mouse over it, you will see some video player controls that you can take advantage of. If you mouse off of it, they will go away. Mouse back on, you'll see they'll reappear. So if you need to use those video controls, feel free to do so. And now let's watch and see how we solve this problem. Okay, let's take a look at how we would approach Part A, where we'll compute the net present value, the profitability index, and the internal rate of return. Now, to save time in this demonstration, I've worked it ahead of time. And you have the cash flows laid out for options A and B. Okay, option A cost $160,000, and option B is $227,000. And then the annual cash flows, which we assume occur at the end of the year, for option A, you can see it was the $75,000 cash inflows less the $35,000 outflows. For option B, those numbers became $80,000 and $30,000 respectively. Okay, there's no change every year until the fourth year. With option A, we not only have the $75,000 and the $35,000, let me hit the F2, but then we have to subtract the $60,000 cost to rebuild, which we assume comes at the end of year 4. Now, we don't have that with option B. With an 8-year life, the cash flows continue, but the only difference we have is that with option B, there's a $12,000 salvage value. So when I hit the F2 key here, and I know this is, it doesn't all appear on the screen, so if you look up here, you can see it. We see that we have the $80,000 cash inflows less the $30,000 outflows, and we add in the $12,000 salvage value that we expect to get for the equipment at the end of the 8-year life. Okay, now they also give us cost of capital, so let's drop that in. It's 11%, and we'll compute net present value first. Now, I've worked this ahead of time, but I think what I want to do is show you how I came up with the $6,321. I'm going to hit the F2, and I'm going to now hit the formula bar with only the NPV formula added. Then I'll bring this onto your screen so you can see what it's asking for. First it asks for the rate, and in B12 we've typed in 11%. I'll show you that's where B12 is. Okay, then we give it the values. Now notice that the values start in B4 and run through B11. So we have B4 through cell B11. What's critical is that you recognize that the cash flows start at the end of the first period. The cash flows that we pay initially, which is at point 0 right now, do not get included in the NPV formula because the NPV formula assumes that the first cash flow occurs at the end of the first year. Okay, so once we have that, we've got the cash flows, the NPV of years 1 through years 8. Now I'm going to hit enter, but we're not done. Since we've only considered the cash flows from from periods 1 through 7, we still need to add in, on a net present value basis, the cash flows that we incurred right now. Well, the net present value of any amount spent right now is that amount times 1, right? There's no fancy formula to determine net present value. The net present value of money either received or spent right now is that value. So we add in that negative amount, and I've showed the cash flow as a negative, and that gives us a net present value of $6,321. Now all we need to do is copy that formula over to B, and we have the exact same information. Okay? And B is obviously a much higher net present value with $35,513. Now, Profitability Index relies on the formula of the present value of the net cash flows divided by the initial investment. All right, well, we have the net cash flows. Let me work this the long way. I'm going to bring this to light and show you how we calculate it. First, you can see there's the NPV divided by a negative B3. Let me get rid of the negative B3 and we'll re-add that. And I'll hit the F2 and you see, to get the numerator, we have to determine the present value of the net cash flows. So using 11%, we drop in B4, the range B4 to B11. That's the same range you've seen before. Okay, why are we only using B4 to B11? Because those are the net cash inflows we're concerned with. We ignore the actual initial cost of investment when we calculate profitability, and instead put that on the bottom, which you'll see now. I'll enter it as the denominator. And I need to make that a positive number, so I'll subtract 160,000, which makes it a positive number. So now when I have the net present value of the cash flows from periods 1 through however long the project runs, divided by the initial cash outlay of 160,000, I'm able to compute the profitability index. And by the way, that shouldn't be a dollar sign. That should be 1.04 because it's an index. And again, we can copy that over. You get the same effect for B. The net present value of the cash flows from years 1 through whenever, divided by the cash outflow. But we turn the cash outflow into a positive number before we determine the index. Okay, and then finally we determine internal rate of return. An internal rate of return using Excel, you don't have to worry about when the period begins. You tell it the values. So in this case, you see we're giving it the values from B3 all the way through. So it's that entire range from period 0 through period 8. With internal rate of return, it is assuming the timing of the cash flows, and the first one starts the calculation in effect. So we don't have to worry about considering period 0 capital expenditures outside the formula. With internal rate of return, it works. And then they ask for a guess. I usually use 10%, but if they've given you the cost of capital, use the cost of capital. That's just a good way to come up with a fair answer. And what we get is 12% for option A and 15% for option B. Now you could carry these out to more decimal places if you wanted to, but for my purposes I think 12 and 15 is close enough. And this illustrates NPV, PI, and IRR. Part B says which option should we accept. Well, clearly NPV is higher, profitability index is higher, and the internal rate of return is higher, so the better option is option B.